All right, it is 1:30 and we are live, so let's get started. Thank you everyone again for joining us today at TMOS NLP. I hope you have enjoyed the talks as much as I have. Two quick reminders before I introduce our next speaker. The first is to check out some of our sponsor booths, which you can navigate to by clicking the booth icon to your left for a chance to win some amazing prizes, including a custom pair of Nikes and an Amazon gift card. The next reminder is that TMOS 2021, which is our annual summit, is coming up on November 15th to the 18th. So look forward to early bird tickets, which will be on sale this week. Now, without further ado, I'd like to introduce our next speaker, Jérôme Massot. Jérôme's background is in geoscience and has worked in the field for over 20 years. He also specializes in the field of AI and NLP. Jérôme works as a Semantic technological lead and NLP researcher on behalf of TotalEnergies, embedded with the Google Cloud team in Sunnyvale, California. Jérôme recently joined Schlumberger's Software Technology Innovation Center in Menlo-Park, California, to continue machine learning and NLP in geoscience domain. He will be giving us a talk on semantic AI and knowledge extraction in geosciences without GTP3. Please give a warm welcome in chat to Jérôme.
Thank you, everyone, for joining me for this presentation. So thank you for the introduction. So I will go quite quickly on this slide because it was dedicated to introduce Schlumberger and the STIC Center, but you have already done that. And I will go to the heart of this presentation is how to use NLP technology and knowledge extraction technology to work in the geoscience. So this morning, I have followed with great attention and pleasure the talk from Ahmed and the talk from Rachel. And I will tell you that today I am a little bit like the villain of the day, because I will show you that maybe despite the great success of NLP and AI, there is still a lot of, I would say, progress and effort to be done to have these tools really valuable in the industry. So the first question people can ask us is why we don't use only Google search for our geoscience application. And this is, for example, the result that I get from Google when I ask the question, what is carbon capture? And I will focus this presentation on Q&A technologies because it's the technology that the people are looking for immediately when we try to deploy NLP application in industry. So if I ask this question to Google, first I have a result which can be a corpus of document. But I have also a similarity questions that Google is proposing me. I have a summarization and translation because you see that here the right widget is in French and it proposed me a summarization of the topic I asked for. And I have, I would say, enrich response because Google search give me pictures and videos related to these questions. It seems to be correct, but in fact, when you are a subject matter expert of this domain, you realize that Google search has retrieved some information about sequestration, which is a little bit different than the capture. Carbon capture is not exactly the same as carbon sequestration. The other problem is that what about doing the same search engine on your own private data? It's not possible to easily deploy Google search for your own private data. So what can we do to mimic this in our private data industry? So I will start to show you why, in my perspective as an industrial practitioner, the latest large language model are very disappointing. And after that, I will introduce how we will what we are doing in real life when it's time to work with NLP and knowledge management and extraction for geoscience. Alors, I will summarize that as 4 seasons of language models, and I will show you how we can very quickly lose budget and management confidence when we are using a large language model without great care. In 2017, 18 and 19, we had the attention is all you need revolution with the transformer architecture. And from my perspective as an NLP practitioner, I was totally mad about that because it was plenty of hope. We have the self-attention approach. We will not be anymore mandatory to use sequential recurrent network. So I was plenty of hope when I saw contextual embeddings like Elmo or other model like BERT appearing on the research and academic side. And it was definitely for me an epiphany when I was focusing on the possibilities offered by these technologies. The summer was in 2019 and 2020, in fact, when we have seen on the press this news about the revolution of NLP by using transformer architectures. And in fact, the tech industry and even the academic just emphasize the movement by creating big model and large language model bigger and bigger and bigger until we achieve this monstrous GPT-3 model. And definitely these foundation models, as Stanford described them, was definitely a big hope for me as an industrial practitioner, because it seems to me that it was possible limitless technologies and the possibility to homogeneize these models for a multitask completion was a very promising technology. Unfortunately, in 2020 and more this year, it appears that these models, despite their quality, they are very brittle. And for example, as an example for a Q&A, these models are very extra sensitive to minor change, which can affect the context. So, for example, if I have this paragraph of text describing the usage of oxide to capture CO2, and if I ask the questions, what was the possible method to capture CO2, the answer is oxide. And this is correct. The answer is located in the first sentence. But now, if I take the same text, but I remove the sentence in green, I keep only the first sentence where the answer is located. But if I ask again the same question using the same pipeline based on the same pre-trained model, I have a totally different answer, which is not anymore correct. And this is to illustrate the extra sensitivity of these models, which definitely are the state-of-the-art models, but for Q&A in this, for example, carbon capture domain. The second problem is that the very famous problem of anchoring. If I take this picture and I ask questions and I ask the language model plugged to, I will say, Vision AI to describe the kind of mustache, he will answer bananas, which is correct. If I ask how many bananas in the picture, he will tell me 2, which is correct. But if I ask the 2 other questions, how many people in the picture, he will continue to answer 2. And what is the air made of, he will continue to answer bananas. It's because, in fact, the trigger of these question and answer results are not the mustache or bananas keywords, but they are much more the what and how many tokens in the sentence. And finally, these models are lacking consistency. We don't have consistency between the question we can ask, because these models are not dedicated to make some reasoning from the context of text or from the image applied to the questions. Alors, Is the winter is coming? Is winter coming from NLP when it's time to deploy this technology in industrial niche, such as geoscience or carbon sequestration? I will say there is a big risk because there is a big difference between the academic or the tech industry confidence, where in fact the confidence is needed to publish papers, for example, with a great success. There is a big difference between this confidence and what I could call the trust that is needed by industrial manager to deploy solutions in order to make a business decision. And this is not a problem of competency because the industry knows that in the tech and academic world, you have people and you are competent in your domain. There is a much bigger challenge when it's time to interpret the models, especially when it's a large language model. People don't understand anymore what the model are doing, and there is always a trade-off between a better accuracy versus easier interpretability. And maybe a more problematic fact is a larger gap between the loss or the metrics the people use to train this large language model and the business metric that the people need when it's time to deploy this model in industries. And you can look at this graphic made by Berkeley. In fact, it's very interesting to see that when you ask and when you evaluate the performance of this large language model in terms of common sense and linguistics, they are quite similar. But in fact, when you try to evaluate the same answer or the same performance of these models in terms of knowledge, especially when the knowledge is a very specific knowledge, you see the gap is huge, in fact. So the business metrics is only poorly proxied by the AI losses and metrics that the people are using to train the model. So the solution exists. We need to deploy and to create more data sets for fine-tuning. This is definitely a mandatory task to be done, and this will be done on the industrial side. It's not a work to be done by academic or tech companies, but definitely by the industry. But we also need to systematically create data set to evaluate the failure in the linguistic to avoid extra sensitivity that we have seen on the previous slide. And we also need to emphasize alignment to create a data set which is more based on knowledge than just linguistics or common sense. So now, what are the solutions today, what we are employing in the industry, especially in the geoscience industry, and how to consolidate the future NLP in industry at the same time? So first, we need to create a bigger shared corpora, open source, to give access to text in the specific domain more easily than today. The second thing is to create, share, and develop ontologies which are really related to the specific industrial niche that we deal with, but these ontologies have also to be compatible with AI and NLP. It's not very interesting to provide, for example, very specific ontologies with millions of entities, where in fact we will not be able to use this ontology to train or to fine-tune a very large language model due to computation power limitation or the AI engine capabilities. And finally, what we also need is to reuse and to rediscover the knowledge bases that exist in the industry and to use this language basis as a very valuable information to be used directly to extract the information or also to be used to self-label a huge amount of data in order to train and to fine-tune this language model. A huge quantity of information exists in database, in taxonomies, in glossaries available today, and it will be a big mistake not to use that to label new data sets for this purpose. Alors, how to label data set? efficiently. As you know, in the industry, you will find a lot of people who want to use AI, but you will find quasi nobody who wants to spend money or time to label data. So it's where programmatically labeling is very valuable. And for example, by combining glossaries, dictionaries, regular expression with a tool like Snorkel, you multiply and demultiply the labeling power available in industry with only a very short, very cost-effective investment. The second thing is to use already a knowledge base and, for example, database and graph base to automatically label data using, for example, Sparkle. For example, in this case, imagine that a human being has labeled one entity in one sentence of a text. Is it possible to use Sparkle to automatically question a knowledge base to try to extract the possible entity related to this human label entity in order to automatically label or propose label of the text automatically? I think it's possible, and it's what we try to do in our geoscience industry. Of course, when it's done by Snorkel or when it's done by knowledge extraction from a knowledge graph, it's important to clean the data that we have labeled semi-automatically. And this step of data cleaning and supervision is mandatory, especially in the industry. And this step needs subject matter expert to be done correctly. So this is an example. In fact, we take some glossaries, we take some dictionaries, we take some knowledge base, and we can automatically tag, for example, name entities in a corpus, a very long corpus. And we can also use regular expression to, for example, extract dates, extract values, properties, where in fact we can use units to create regex. And this could be used as a direct extraction. And we can extract knowledge in a very valuable and efficient manner by using that. It's not AI, it's not definitely NLP using deep learning, but it's very valuable. But also, what is recommended and what is mandatory to propagate and to emphasize is the use of semi-automatic labeling to create supervised label dataset in order to fine-tune, for example, BERT to recognize geoscience name entity. And this is done very quickly with, once again, a very short effort in terms of time and people workforce. And with only 3,000 sentences corresponding to 13,000 labels for name entities, it's very possible to train or to fine-tune a BERT model and to obtain a name entity recognition model with very, I would say, honorable scores and metrics to provide value in the industrial domain. Finally, I want also to focus on the, I would say, inclusive context question answering. For the moment, a lot of the Q&A technology used in the industry is based on extractive context-based Q&A. So in fact, the computer will only find answer from a context if the answer is located in this context. And of course, a lot of the challenge we have is to rank the context in order to have the Q&A engine more performant and to create less latency for the user. But the other thing we can do is to try to enrich this Q&A engine using the context around the paragraph of text, for example, where the answer has been located. And this is done by analyzing the layout of the document and the proximity of the knowledge information using this layout as a metadata. And this is done by using a graph. And of course, for us, who are geoscientists, it's often the case that a picture is worth 10,000 words. And very valuable information can be retrieved not from the text itself, but from the figure or from the table, which are located at the very close proximity in the original document. And this is done by just analyzing the layout using AI. So it's not exactly NLP, but is knowledge extraction technology based on AI. And you can represent now document and corpus using a very, I will say, powerful graph. And using this graph is now possible to, in fact, to balance the deficiencies of the language model by analyzing the corpus of the document and by enriching the answer from the text by answer coming from figures of table. And just to show you that, in fact, Google is also analyzing the layout of the document, but this time, as others in the tech industry, they try to, in fact, to analyze the document layout using transformer, and not using transformer, using self-attention layout matrix to reproduce this kind of document to create synthetic data sets. So the layout of the document is also very valuable to extract this information. Just to summary and the conclusion, I will say foundation models are very performant, but unfortunately, today they are still not sufficient to direct use in industrial domain. And to be valuable in the specific industrial domain, we need to go back to a data-centric approach. For example, no one is expecting some value from a GPT-4 or GPT-5, but there is more value maybe in some such tools such as Snorkel or analyzing knowledge base with Sparkle, for example. Heuristic and glossary solutions are efficient, even if they are not NLP or AI, and they are more. They represent a large part of the tools available today when it's time to deploy a knowledge extraction engine in the industry. And finally, the knowledge what you can have from a document corpus is not only the content, but is also the layout. And analyzing the layout as a metadata and including this metadata in a Q&A engine is something that we need to do because information is in the text, but also in the figure and in the table surrounding the text. So if you have some questions.
Thank you, Jérôme, for the really insightful talk. So we do have some time for some questions. I just want to give a real quick heads up that our last session will start at 4:10, but if we have questions still, we'll continue going over time. But if you want to head on over to that, you're welcome to do so. So if you have any questions, just type in the chat and I'll do my best to get to them. I guess to start off, about the solutions, I think it was the point that you made about with using large language models or foundational models out of the box, you lose budget and management trust. I think that's something that within industry, for example, OpenAI really tries to sell GPT-3 as something that you could use out of the box. It's not there yet, and that's something that it's a bit overhyping our expectations in that regard. In terms of solutions, you kind of propose two. I just want to confirm that you kind of propose two directions, right? One is to fine tune the NLP model, so the for example GPT-3, and using, for example, knowledge extraction, better open source corpuses. The end goal is to get better training data for the NLP model. And then the other direction is, no, go ahead.
Yeah. In fact, you're totally right. I think it's a way we need to have a win-win solution. We cannot say I stick in the heuristic, grammar-based, rule-based approach because it will be a mistake. But today, it's the only way to achieve metrics on a very specific data set, to achieve metrics which can be good enough to have a manager deciding to industrialize that. But it will be for sure too much overfitting. But we can use the same approach, but this time to use the labeled dataset not to serve the knowledge, but to use this labeled dataset, which has been labeled in a, I would say, semi-supervised way, to fine-tune the language model. And definitely, I'm a big promoter of fine-tuning a language model, even creating or training a language model from scratch if you have enough data. This morning, Ahmed, it was very interesting. He said, yes, for example, we can fine-tune a language model if we have a very small data set, 1 terabyte or 2 terabyte of data. But Ahmed, if you listen to me, 1 terabyte or 2 terabyte of data is huge. You will never have this kind of data size in the industrial domain, at least as far as I know. So fine-tuning is definitely a mandatory step, but fine-tuning with a consequent data set and the volume and the quality of these data sets for fine-tuning can be achieved only by semi-supervised programmatically labeling.
Mm-hmm. Mm-hmm. And then I guess to the other side, the other solution would be kind of the opposite way around, where you're using these the language model to kind of inform the knowledge database, right? So
yes, but today it's very funny. A lot of people are emphasizing the need to use unstructured data and to extract the knowledge from unstructured data. This is totally correct, but they don't realize that for the last 50 years, people manually extract data to put that in a database. And it will be a big mistake to try to reinvent the wheel by trying to re-extract the knowledge from unstructured data when this data has been already extracted and cleaned in database. So the idea is to take the benefits of the database, not only to serve the knowledge to the final user, but to take this database, to transform the database in knowledge base, and to use this knowledge base to label dataset, to re-inject into the large language model.
Mm-hmm, mm-hmm. I guess more specifically, one of the questions is, how are you applying this in geoscience context? Is there a specific problem in entire field?
Mm-hmm. Alors, the specific problem in geoscience, especially in for example, the oil and gas business, is first to access the documents, the corpus. The oil and gas company or energy company, they don't want to share things. There is a cult of the secrecy. And for example, it's quasi impossible to find a voluminous and corpus of document, open source. Same for glossaries, taxonomies, ontologies. It's very difficult to have open source data. So first, in geoscience, there is a problem to access the data. The second problem is that it's a very specific knowledge, very specific niche of technology where you need to be expert to label things. And finally, what the problem is with advanced, I will say, industry, when you serve, for example, I am a big fan of Rasa, and I listened to Rachel this morning. Rasa, it's a terrific, is a very good tool to create chatbot. But when you deploy a chatbot dedicated to, I will say, the absorption of CO2, you need to have a matrix which is very high because you want to target customers who are subject matter expert. When you are deploying a chatbot for a pizza, except if it's for expert pizzaiolo in Italy, you can maybe achieve metrics which are a little bit less for the technology about how to make pizza. It's not the same business metrics. And the idea is the business metrics that you should expect and you should reach when you try to deploy a tool for a subject matter expert is not the same as the business metrics you need to achieve when you deploy the model or the tool for a general public.
Mm-hmm. And I guess continuing on the topic of curating data, you mentioned that a lot of companies, they have a lot of proprietary data that they don't want to share, and it's and the field is extremely specialized and requires domain experts that, again, have 20 plus years of experience like you. So to pick your brain on this, who do you think should take on this responsibility on getting the guidelines for labelers and considering some of the
yes. By experience, I will say the responsibility is definitely on the industrial side. We cannot expect Google, Facebook, Rasa, Amazon to have subject matter expert in geoscience. So definitely the responsibility to create these data sets is from the industrial side. But it is a teamwork. For example, when I see the latest progress made by Snorkel AI, I realize that the responsibility of the tech companies or academic people is to provide tools, techniques to ease this labeling process. The work done by Spacey with Prodigy is very good. The work done by Snorkel is very good. So it's definitely a win-win situation. The tech and the academic give us the best tools and the best, I would say, recipe to work in the Spacey vocabulary, the best recipe to label data efficiently, and the responsibility of the industry people is to provide subject matter expert and corpus to create the dataset.
And do you think it should be one single organization, or should individual organizations kind of use their tool to continue building on to that?
Honestly, to be successful, and it has been demonstrated with the language model and the foundation model, to achieve the emergence and the homogenization, it's difficult to say in English, homogenization characteristics, we need self-supervising, but we need scale. If we cannot achieve a scale, we will fail. And the only way to achieve scale is to share things. I am a promoter of open source, share corpus, ontologies, taxonomies, especially, for example, if we talk about carbon sequestration and capture carbon in the atmosphere. It's definitely a mandatory challenge that concerns, and that is a responsibility of anyone. So for this particular subject, we need to be able to embark all the industrial actors, all the academic, all the tech companies, all together to create a huge share repository to have, let's say, the same as we have done for the COVID. We need to do the same, for example, for carbon capture challenge. And this will be the only way to achieve the scale needed to have good metrics for a large language model.
Because a lot of companies could be investing millions or billions of dollars into their own methodology, their own process, but without coming together, you might not reach that critical point where
exactly.
you get the momentum.
And because I know that Bezos is watching us, and I know that Larry Page is watching us, and Elon Musk is watching us at that moment, I tell them it's time to do the same for carbon capture as we have done for COVID. So give us billion, we can do after that.
Yeah, definitely. So I guess our next question is more about your own use case. How much training data did you use regex before you are comfortable with moving towards Snorkel for labeling?
Okay, in terms of regex, I used all the traditional regex recipe, for example, to extract dates, to extract. The good things in geoscience is usually we are very interested by extracting values. For example, permeability, which is the property of a rocks to flow fluids. Usually a permeability is expressed in millidarcy. So in the text, you have always the unit close to, for example, a numerical value. So just by looking all the different units corresponding to each different properties of the rocks, for example, you can create a very robust regex analyzing the presence of a numerical value just in front of the 2 or 3 letter character corresponding to the unit. So it's very easy to do that. So if we do that for regex, if we use the traditional name entity recognition, location, person, etc., it's quite easy to work with the regex. The other things is that geoscience, like other industrial domain, we are big fan of acronym. And acronym is something that we are using. So sometimes, for example, when we drill a well, the acquisition of the data is made using tools. And these tools, usually they follow a format for the acronym, which is known by advance. So doing that it's very possible to do, I would say, robust regex.
Mm-hmm. Mm-hmm. So there's a lot of very domain specific
yes,
methodologies that can be.
It's very possible, but as Rachel told us before this morning, it's very time consuming. Mm-hmm. There is no free lunch. You need to invest time to get fruits at the end.
Definitely. And then once you get to that, I guess, point where you could start moving to more semi-automation with Snorkel.
Exactly.
Have you ever, I guess, using kind of combining the two ideas of like having a knowledge base, which is not reinventing a wheel. We've spent such a long time curating databases that has been cleaned. And if we could represent that as like a knowledge database, but also leveraging a fine-tuned language model to kind of do name entity recognition or extraction to kind of further propel the knowledge base. Because I guess one aspect of wanting to do unsupervised or self-supervised learning is the idea that we're working with the data as raw as possible with unintentional, inherently more noise, but it has the most, I guess, fundamental knowledge in it, right?
Yeah, I totally agree with you. It's very important. What is important, and you mentioned the term raw data, is important because we have to be careful sometimes, because using knowledge database and transform the database in knowledge base, we could also introduce bias very quickly. Because when the people are creating a database, they have created the database with one purpose, with one objective. And the dependency between, for example, the tables in a database could give you one possible ontology, one possible dependency that you could use. But we always need to keep in mind that this dependency between the entities have been inherited from tables. So, and the tables have been done, and the dependency between the tables, the schema of the database has been done with one particular objective, which is not the universal objectives. So we need to be careful about that. But it's better to use this kind of shortcut to achieve, I would say, the critical mass that trigger the semi-supervised labeling process with Snorkel than to do nothing. But we need to be careful about the bias we could introduce by using knowledge base.
And definitely, as you mentioned earlier, that the data cleaning and subject matter just being able to validate is important in that part.
Data curation is mandatory, especially when it's made by semi-supervised technology.
And I guess more of a fun question is, are there any fun geoscience facts that you think most people should know, but you don't? But we don't.
Funny what?
Like any geoscience facts that you think that the audience should know?
I will say geoscience. I don't know if it's fun, but I will just give a taste of responsibility. Today, we are witnessing a shift in the energy domain, where we try to move from, I will say, hydrocarbon-based energy to a new sustainable source of energy, which is globally good. But in geoscience, we need technical people in geoscience, in NLP. It's a message I want to go to pass through your channel today. Don't put away geoscience just because it's related to oil and gas. geoscience today is also related to carbon sequestration, to sustainability, how to find rare earth needed in the battery, etc., etc. And this industry is reinventing itself and needs you as a technical expert in NLP and AI. Some companies, they decide they don't work with geoscience, they don't work with oil and gas for maybe true reasons or philosophical reasons. But you need to go and to see beyond oil and gas. We need your expertise to do something else and to go beyond oil and gas thanks to your knowledge.
Definitely. And again, the field is really reinventing itself and moving to a whole nother moving away from oil and gas. So I think that's it for the questions. Thank you so much for giving such amazing, I guess, thought-provoking information to us and kind of answering all our questions. So thank you so much, Jérôme, and thank you everyone in the audience.